array implementation of collection ADTs. Alright, so let's start. Okay, so the learning outcome upon finishing these topics, you need to, or you're able to implement your ADT list, stack, and queue using array. You also must know the strength and weakness of using arrays, and as well as the efficiency, alright, of array implementation. Okay. Now let's recall your ADT specifications. Okay, how do you create your ADT? First, you have to write your ADT specifications. Alright, you guys still remember how to write ADT specifications or not? Alright, so I think during the practical class also you will have gone through. Okay, so please take a look at the steps. Let me download something. Okay, so here you write your ADT specification which describe the characteristic of the data type and set of operations for manipulating the data, whereby you shouldn't include any implementations of the operations. Okay. Next, we have to implement the ADTs, where you need to write your interface, right? Interface will be all the operations that you have declared, you created in your ADT specifications. Next, we have to write our Java class. This is where you do implementations, determine how to represent the data, implement all the operations from your interface. And finally, the third step is to use the ADT in your client program, your driver program, your applications. Okay? So first, right, to recall back again, what is your ADT collection? Alright, ADT that can store a collection of objects. It's a linear collection, store data in a linear sequence. So we have list, stack, and queue. Alright, they only differ in terms of restriction. To add, how we add our data into the collections, how we remove, or how we access, or how we search the data from the collections. Okay, so if you take a look at a list, there's no restrictions. You can add anywhere. Alright, you can access from the beginning, or you can use an index. For stack, of course, we have restrictions where you can only add on the top of the stack and remove from the top of the stack. Okay, this is a last in, first out. Queue, you have first in, first out. Okay, the way they organize the data is first data in, first data will be processed out. Okay, alright. Okay, now, so let's take a look at list again. And we will take a look at lists and how we're going to implement lists in our array. Okay, as you know, lists provides a way to organize data, right? A list, of course, you organize in certain order. Okay. Sample of list, applications, playlist, song list, remember? Okay, you guys remember or not? Okay, so those are the lists. Okay. So the basic operation you can perform on a list is to add, to remove. Add means we can add at the end, or you can add anywhere. Okay, you can remove an item, you can replace an entry, you can get an entry at a specific position, you can count how many entry, and you can check if a list is full or empty. So these are some of the basic operations. Okay. Now, let's take a look at how to write your ADT list. Okay, so we're going to refer to the list ADT specifications. Okay, Okay, let's take a look at this. Alright, so this is our ADT list. Okay. ADT list, the description for ADT list. First you write the title. Next is you have to write the description. Okay. So the description of list, what is it? A list is a linear collection of entry of type T. Alright. T is generic type, which allows duplicate elements. Any entry may be added at the specific positions or at the end of list. A list position starts from 1. Okay? So this is the description of what this ADT is all about. Okay? Now, we have basic operation. Okay, we talked about basic operation just now. Of our list is add. We can add at the end or we can add anywhere, any positions. Okay, so we have to have a method that allows us to add the entry. Add means add new entry to the end of list. We also have another method called add also. So this method, alright, this method indicates where we want to add. So we have the parameters, the coming in position, and this is the data. Alright. Now what is this T? Let's say generic type. Type T. Alright, type T. Now I'll give you a scenario, okay? Now, computer science can only be taken by mail. Cannot, right? Can only be taken by Chinese. Can I put like that? I'm not racist here, I'm just giving an example. Can I say computer science can only be taken by Chinese? Mail. Okay? Or Malaysian. Alright? Yeah? What am I doing? I'm setting a condition. Right? Now if I put T means what? It's generic. That means I can store item in my list. I can store a female name. I can store a male name. I can store a student list. I can store a movie list. I can use the same to store a book list, right? I can store a customer list. Do you understand? T is generic. So I can use this list for any application. Alright? Generic, okay, T. Okay, so here we have preconditions. Alright, as I told you before, preconditions depend on the situation. If there is a precondition, you add in. If it's not, you don't add. For example, here, there's no preconditions and there's no return. But you must write descriptions and post-condition. After executing this method, what will happen? Okay, new entry has been added at end of list. Okay, this one, alright, your post condition will be new entry has been added to the indicated position of the list. Okay, so that's a two different type of add. Similarly, we have remove, clear, replace, and you have get entry, contain, get number of entries. This is like a count, okay? And then is empty is full. Alright, okay? Do you understand? So what is this is full? Determine whether the list is full. Alright, is there any coding here? It's no implementation, just abstract way of describing the method. Okay? Okay? So first we have to create or we have to write the ADT specification. Alright, so we've already seen the sample. Okay, write the ADT specification. Now we have to focus only on what are the operation and what operation do. Okay, not how. Okay, just now remember we have two types of operation for add. Okay, so you know one is to add at the end, one is to add at the position. Okay, so you only need to know that. Okay, or you only need to indicate that in your ADT specifications. Okay. Now at this point, list is an abstract data type. Okay. Okay. Now some of the issues that you have to consider for the operation. Any operation you are creating, so you need to consider some of the factors. Okay. So here we have add, remove, replace, get entry work okay when valid position is given. Alright? So when I say add into a position, okay, if my array size is 5 and I given the position as 10, obviously you can't add at the position 10 when your size is 10, isn't it? 5, right? Yeah? So these are the things that you have to take into consideration. Remove, replace, get entry not meaningful on the empty list. Okay? So what happens if your list becomes full? What happened to add? Can we add anymore? What happened to the function? Okay? When you invoke the add method, do you think your data will be overwritten, erased? Okay? Lost? Alright, so these are the things that you have to consider. So what you have to do is that, alright, when you specify your ADT, you need to decide how to handle special, unusual condition. Alright, then you must indicate in your ADT specification detail on how you're gonna solve or how you're gonna handle this kind of situation. Alright. Okay, so for example, you will have, okay, here you can have a preconditions. So for instance, the new entry must be between 1 to total entry. So these are some of the things that you can put in as handling a special situation. Okay, all right. So position. Given position must be between 1 to total entry. Okay, so something like this you have to include in. Alright? Okay, now some of the possible solutions you can have is, now assume invalid situation will not occur. So that means our programming is very good. So we will just assume this one is not going to occur. Or you just ignore any invalid situation. You know, you don't put after if, then else, you just leave it empty. Alright, ignore it. Okay. Or make any reasonable assumptions. Okay. So assuming their user will add something in, okay, input something, then you predict what are the ways that the system should act. Alright. Or you can have a boolean. Okay, boolean value to return to indicate true or false for true exceptions. Okay. Alright, so that is for your ADT specifications. Alright. So ADT specification, I like to reiterate again, coursework and exams. You must know the format, how to write, what to write, okay, and how to get the necessary information from the question to write your ADT. Okay? Alright, next, okay, next part is that we're going to implement the list ADT. Yeah? Alright, so we're going to write our interface. Okay? So this interface, okay, we're going to take all the operations that we declared in our ADT specifications, then we're gonna declare it in our interface. Okay, so these methods going to be abstract methods. So let's take a look at the example. All right, you guys can see. Okay, so this is your ADT specifications, yeah. Interface. Alright, so here you have public interface. Now this is my first method operation. Okay, you see that this is my first method. Okay, what is the method? Add new entry. Okay, so I declare. Okay, Boolean type. I'm going to add the new entry. This is to add new entry to the end of the list. Okay, and we have the next method is add to the given position. Add a new entry, a specific position within the list. Alright, so is there any implementation? Is there any if then else here? Alright, so we just in abstract, okay, we declare all the methods, okay, all the methods that we specified here in our ADT list. Okay, so all the methods will be listed here. So we have add, remove, clear, replace, get entry, contain, empty, and so forth. Okay, so all this we declare. Alright, so we declare it as an interface file. Alright, okay, so now we have to write our implementation. So we have to implement the methods. Now there are a few things we need to take a look. We have data field in the Java class. Array, alright? Remember, we need to implement our collection using array implementation. First of all, do you know what is array? Yes, you should know this. Array is what? What is array? Yes, I know array, but what is array? What do you think? Index starts with 0 or 1? 0, okay. What is it? What is array? Okay, Google lah. All of you have your handphone, your IT savvy, Google and read only. Alright? So you should know what is array. I'm not going to go through so much on how to declare array. What is the one-dimension array? What is two-dimension array? Okay, we already above that. Okay, higher level. Okay. Anyhow, array is used to store our data. Alright, array used to store collections of data. Alright. So we're going to use array to store element of the list. So we declare our array. Okay, T. Alright, it's not integer, string, character. It's a T type, generic type. Okay, so generic. Okay, depend on the client program. If client program is using integer, then T become the integer value. Okay, if a client program is using a string, then it becomes string. Okay? Alright? Okay, T represents the data type of the entry in the list. Okay? If you are putting in a student ID list, alright, then it becomes the integer. Can you understand? Okay? Alright, so next of course we have to declare the number of entry. This is the current number of entry in our list. Okay. Alright, so as I explained earlier, collection, the data type. So we usually name it as the identifier T and close it in angle bracket. So public interface, list interface, and T. Right, so let's check here. Alright, so this is T here. Okay, so this is how we indicate. I think during your practical class, you created your interface, correct? Yeah, but you didn't do this, right? Okay, so that one is a normal list. We are using our what do you call a framework collection. So now we want to code our own list. Okay. All right. So now next is here. Okay. Alright, so here just the argument when you pass, then of course you will pass it as a string. As I explained earlier, the client side, you can pass it as a string, you can pass it as a entity, you can pass it as integer and so forth. Okay? Alright, so now we have to implement the interface, and we have to implement all the core operations as well as the utility operations of the list. Okay? So now let's take a look at add. How are you going to implement add? Okay? Remember we need to add data into list, right? So we already specified the add method. Okay, we already created the after method in our interface. Now we have to implement. So before we write the code, let's take a look at the concept of add. Okay, add new entry, add a new entry at the end of the list. Okay, assign new value at the end. Then we have to increment length of the list. Okay, so assuming we have an array, starting index is 0. Alright, then we before this, okay, alright, you can see that we have 1, 2, 3, 4. So there are 4 elements here, length is 4. Alright, so I'm going to add at the end. Okay, and as you can see, my length will increase. Okay, and then the new items will be, or element will be added into the list at the end. Alright, okay? So this is how we illustrate. Okay? Now add into a position. Okay? Add item at a specific position. Okay, let's say we have names like this. Okay? Now Alice until Hallie. Alright, now let's say if I want to insert color, making room to insert color as the third entry in the array. So what we have to do is that we have to shift the elements. Okay, as you can see here, shift element. Now how are we going to shift element? Alright, we need to write a utility method we call make room. Okay, make room is basically to shift the element, alright, to have their space so the new entry can be added to that position. Alright, understand that? So make room. Okay, we have to create a code for make room as well. We have to implement make room also. Alright? Now so this is the object reference for array. Array object actually contains reference to those objects. Okay? So here basically this is how array should look like, okay? But then again, for simplicity, we do like this, okay? So some of the diagrams, of course, from now on might look like this, so don't get confused with the same thing, okay? Alright, remove, okay? Remove item at the specific position. You must shift existing entry to avoid gap. So we're going to use remove gap utility method. Alright, so method also must handle error situation when the position specified is invalid, when removes is called when the list is empty, and invalid call return a null value. So these are some of the error situation error handling. You have to take a look. Okay, so this is to remove. Let's say we want to remove Bob. Alright, you have to do shifting. Okay, now shifting, if you shift house, for example, scenario, okay, you're going to incur cost or what? Moving from one house to another house. Of course, you have to carry a lot of your furniture and everything, right? You're going to incur cost, right? Do you think here we're going to incur cost? What kind of cost? Efficiency, yeah? Remember resources and time. Alright, when you do shifting, remember this. Okay, later we will take a look at it. Okay, Now, okay, so other methods, for example, is replace get entry and container. Alright. Now, how do you think we're going to replace? What are some of the assumptions that you're going to make? Replace. You want to replace something. Can you replace an empty list? Cannot, right. Okay, what if that whatever item you want to replace doesn't exist? Right? So that's another item also you need to take a look at it. Contain. Contain is search. Alright? What if we cannot find the item? Should you return true or false? Alright? So you have to think about that as well. Okay? Alright, now let's take a look at the implementations. Alright. Okay, array implementation. Alright? So we're going to implement our list interface. Alright, this is our array. So remember, I told you just now we need to declare two data fields that you have. Array and also number of entry. This is basically the capacity of the array only. Okay, so here, how to add into your list. Alright, so let's take a look at this code. Alright, if you want to add an entry, so this entry is coming from your client program. Okay, depending on what data type to use. Okay, so it comes in our array. Okay, first time to add the data. Our entry, number of entry is 0. So array index 0 will be your new entry. Okay, you understand this line? Yeah? Okay. Now, then of course you have to increase your number of entry. Return true, meaning successfully added. Okay? Alright, now the second time coming in, alright, so entry will come in, new data is coming in. Now what is my number of entries? Increased by 1, right? So now my number is 1. Okay, number of entry is 1. Initial value is 0. But we already add the data in. So my array will be array index 1 equal to the new entry. Okay, so this is how you add. Okay, now let's take a look at add at a given position. Okay, now here, as I said earlier in our precondition, position must be between 1 to total entry plus 1. Okay, so here we have to check whether our new position is more than 1, okay, or equal, and then there you go. Alright, position has to be number of entry plus 1. Okay, and then we have to create, okay, here, make room. Remember, we're adding into a position. Okay, we're adding into a position, we have to create a make room. Alright, make room. Okay, what is the code for make room? Okay, here, I'm going to click here. Alright, so here, moving each entry to higher index, okay, starting at the end of the array and continue until entry at the new index is moved. So I use the loop, alright, to increase my index value, so to move the items. Okay, there you go. Alright, and then only I add the value in. Okay, back. Now here, new position -1, why? Can you think right now? New position -1. Alright, now during practical class, we try to see if there's no -1, what happens? Alright, check. It's all to do with your array indexing. Okay. Alright, so then of course similarly you increase your number of entry. Alright, of course else you become add in return false. Okay. There you go. Alright, Cam? Any issues? Okay. Remove also similar. We have to code. We have to code remove gap. Okay. So here we have remove gap. Okay. Move each entry next lower position starting at the entry after, you can see here, after one remove and continue until end of the array. Okay, so again we'll do this. Okay? Alright, so that is for your array list. Okay, so make sure you take a look at it. Now as you can see, alright, we have ADT specification, you have interface, and then you have your implementation. Your project, you must have your each member, each module must have ADT specification, must have your interface. Whatever you specify must be in your interface. Whatever you declare in your interface, you must have it in your implementation. And then only you create your client program separately. Okay, so your client program, I cannot run here, but client program you create separately. Okay. Alright, you can create separately, okay, to check. Alright, okay. Okay, so here, let's move on. Alright, there's another thing that you need to take a look. Okay, now think about it. If your array becomes full, all the array locations are assigned entry. Okay, what are you gonna do? Okay, what are you gonna do? Alright, what are you gonna do? Alright, just think about it. If this room is full, student need to come in, what would you do? Maybe get more chairs, right? So what would you do? Array is full, what are you gonna get? Okay, think about it. Tell me, what are you gonna get? So if more students coming in, let's say all the chairs filled up, I need to bring more chairs, isn't it? That means more space, correct? So my array is full. So what do I do? What do I do? I increase the capacity, correct? Yes, we will increase the capacity. Alright? So here, okay, I expand the array. I increase the capacity. Alright? Array has a fixed size, no doubt. Okay? Now, if you were to put a large array, of course it's going to take up resources. Okay? So that, in fact, going to reduce your efficiency. Alright? But what if we can dynamically expand? When it becomes full, then we expand. Okay? When it's full only, we bring all the chairs in. Otherwise, we don't. Alright? Do you understand? Okay? So, we do a dynamic expansion. Okay? So, we need to have two extra utility methods. Is array full? We have to determine whether the array is full. If it's full, then we double it. Alright? If it's full, then we double it. That means, it will in real time when the capacity of array is maximized, then we go and double the array. Okay? Alright, so this is how we're gonna expand. Okay? So we take the original So original will have 1, 2, 3, 4, 5 space. Alright. Then we copy. Alright, copy the arrays contained to a larger second array. So this is the larger array. Copy everything in. Okay. So we expand. Alright, we take our array, we expand our array, then we copy our data out. Okay? Alright, so this is the coding for it. Alright, so to double the array, you just take still I cannot use it. Alright, so here 2 times the length. Okay, so that means you double your array size. The length here is to double the size of the array. And this here you have the loop is to copy back the data. Okay. Now remember, okay. Now when you implement, okay, your expansion, okay, when you implement double array, you need to add, okay, that particular method into your add method. Okay, the add method will double the size of array when it becomes full. Okay, so now you have to declare a method is array full. You have to call in your add method. Okay, so this one you will do in your practical class. Do the coding in the practical class. Alright, so now let's take a look at the pros and cons. Okay, the pros and cons of array implementation for list. Okay, remember I talked about shifting. It's going to cost you. Alright, now retrieving an entry is fast. Why retrieving an entry is fast? Array, we use index, so I can retrieve the data very quickly because I just have to refer to the index. Okay, adding at the end is very fast. Okay, add to the end is very fast. In fact, our code also very short. Okay, now problem, adding and removing an entry that is between other entry requires shifting element. Okay, now shifting element is cost. Okay, resources. Increasing the size of array requires copying. Alright, so copying also again is another place where you use resources which can reduce our efficiency. Okay. Alright, so these are the sample code I already showed you. Alright, so you can check that. Sorry, unfortunately we cannot run here. Okay, so they understood enough? Okay. Now, ADT list is already included in your lecture material. Okay. ADT, stack or queue. If you're using for your coursework, you have to come up with your own lah. Alright? Okay, next thing is, okay, for your list, okay, make sure you know your specification, make sure you know what is their interface, how to write the interface, and also the implementation. How can you add into the list, the coding? Okay, it's very important for exams, because for exam you don't have computer in front of you. Alright, so the code you have to write it down, so it's important. Okay. Alright, any question on list? Then we move on to stack. Okay. Alright, stack. Okay, last thing first up. Okay, we have to add on top of the stack. Okay, we have basic operation, push, pop, peek is empty and clear. Alright. Now, consideration using. Right. When you're using array to implement stack, there are a few things you have to take into consideration. First is array's first element should represent the bottom of the stack. Alright, the last occupied location in the array represent the stack top. Do you understand this? Index 0 is bottom. Alright, and the last item you put in will be the top. Alright, so this avoids shifting the element of the array if it was done the other way around. So like this last, for example. Okay, now, so here, okay, here we want to have it as a top, and our 3 will be bottom. Okay, so this one requires shifting. Alright, so it's best is that to have 0 as the bottom, index 3 as the top. Alright, so this is much more easier to access. So because we're going to access to this data out. Alright. Okay, so again implementation. Alright, for your stack. So you have to declare here array, and you have to declare, you have to keep track of your top index. So we have to keep track of the top of the stack. So we declare a variable called top index. Okay. Now top index is to represent the top of your stack. Okay. Earlier we have number of entry for list. Okay. So let's take a look at it first. Okay. So this is your interface. Okay. Push, pop, peak is empty and clear. Erase that. Alright, so here we declare the array and top index. Now let's take a look at the push method. Alright, so let's take a look at push. Okay, how are we going to push the entry into our stack? Add a new item at the top of stack. You increase your top index, assign new value. Right, you assign new value at the array location indicated by the top index. Okay, now. Alright, so here we increase the top. So here we initialize top as -1. If top index is -1, indication that the stack is empty. Okay, if it's -1, it's empty. Okay, now we increase the stack first. So increase means the array will have index 0. Alright, then we have to check here is top index less than the length. Okay, alright, this is to check whether it's full or not. Okay, yes, then you just add into the top index. See that? Yeah. So let's see the difference between this and list. Alright, you see the list? You see the difference? Alright, so here number of entry is 0. Then we increase the number of entry. Based on the number of entry, we add at the end of the list array. And okay, here we increase the size. If we increase the top index, then we add. Okay? Okay? Okay. Now, let's move on. Okay, that is for push. Then we have pop. Okay, pop is to remove. Okay, when we remove, where we remove from, we have to remove from the top. Okay, so I declare a variable called top. If it's not empty, alright, my top index. Okay, this is the element from top index, assign it to this variable, and I return the top. Simple. Alright. So using stack, removing is easier compared to here, because here what we have removed that. Okay, in this case stack we don't have shifting. Alright, we don't have shifting here. So you may think, oh, this is good, this is better. Alright, again depend on your application. Okay. Alright, next. Now let's finish this, then we take a break. Alright, pop. Okay, pop. To illustrate pop, alright, so value 3 we want to return to the client. Alright, now here when we decrease top value, initially our top index is 3. Now our top is 2. You understand? Alright, so our 3 is already no data now already. Okay? Yeah? So now a new top index is 2. So that's why we need to decrease the decrement top index, decrease the value. Alright. Okay. Now, I want you guys to take 5, then we come back and do this exercise. Okay?